Welcome to this session of Business Mathematics. My name is Ashish Jain. I am an assistant professor at the Department of Computer Applications at the Bhopal School of Social Sciences. Our today's topic is percentage. This is a brief outline of our course. I have divided the course into two modules. In the first module, we will look at Introduction to Percentage, relation of ratio, fraction and percentage, properties of percentage and rules of converting values into percentage. In the next module, we would be looking at more details about types of problems in percentage, numerical and word problems in percentage. So let's begin our first module, percentage. Percentage is a comparison between two like quantities in which one quantity must be 100. If you could remember ratios, ratio is also a comparison between two quantities of the same type, but in ratio there is no compulsion that one quantity must be 100. In percentage, out of the two quantities, one quantity must be 100 and that quantity is in denominator. When rate is calculated for 100, it is called percentage or percent. We can use these terms percentage and percent interchangeably, they both mean the same thing. Here the rate percent is a fraction which is of the form such that the denominator of the fraction is 100 and we have the number as the numerator. Let us take an example. A student gets 30 marks out of 50. If the paper is of 100 marks, then the marks of students would have been 30 into 2, which is equal to 60. Thus, marks of students are 60 out of 100. Now, we can represent this in terms of fraction as 60 upon 100 or in terms of percentage as 60%. If you can see here, we have substituted the value of 1 upon 100 as the percentage. So, 1 by 100 is equal to the percentage symbol. Let us look at the definition of percentage. The word percentage is consisting of two words, per and cent. Per means each and cent means 100. Thus, we can say that percentage means for each 100 or on each 100 or in each 100. If we calculate the value of a particular thing in terms of per hundreds, we call that value as a percentage. We use the symbol of percentage to indicate that the value is a percentage value. In mathematics, a percentage is a number or a ratio which is expressed as a fraction of 100. Let us take one example. Suppose we have these 5 boxes. Out of these boxes, one box is of yellow color and the rest 4 boxes are of blue color. Here we can say that we have one yellow box as compared to 4 blue boxes. Hence, the ratio of yellow to blue boxes is 1:4. In terms of fraction, I can write this ratio as 1 upon 4 or we can say that it is equal to 25 upon 100. Since we know that 1 upon 100 is percentage, so in terms of percentage, it can be represented as 25%. Let us look at the relation between ratio, fraction and percentage. A percent is a special ratio that compares any number to 100, where this 100 represents one whole part. For example, comparing 15% and 40% is more easier than comparing ratios 3:20 and 2:5. Take another example. The ratio of outfielders to infielders during a cricket match is 3:6 or which is 1/2. That is 50% of the number of infielders is equal to the number of outfielders. Here we say that the ratio of outfielders in the team is 3:9 and the percent of outfielders in the team is 33 1/3%. Later on we will see how we come to this percentage value. In terms of fractions, a fraction is a number that represents part of a whole part or part of a group. Here the denominator represents the total number of equal parts the whole part can be divided into. For example, in a group of 5 students, we have 4 boys and 1 girl. So in terms of fraction, we can say that the fraction of the group that is female is 1/5, which is equal to 20%, and the fraction of group which is male is 4/5, which is 80%. Here one thing most important is that the denominator will always be 5 because the whole group consists of 5 students. Let us see some uses of percentage. Percentage is commonly used as a common standard of measurement in various commercial applications. It provides uniformity in quantities of the same kind. Percentage makes calculation easier as it is much simpler to work with parts of 100 rather than 2/3, 3/3, thirds, twelfths and so on, especially because quite a lot of fractions do not have an exact, that is non-recurring decimal equivalent. Percentage makes comparison much easier between different percentage which all effectively have the common denominator as 100 than fractions with different denominators. This is partly why so many countries use a metric system of measurement and also a decimal currency. Percentages are widely used in business world in terms of discounts, commission, brokerage, interests, dividend, profit and loss, etc. Percentage is also used in calculation of income tax, water tax, electricity bills, insurance premium, marks obtained in an examination, composition of mixtures, etc. Let us look at some of the properties of percentage. In comparing two quantities, there should be homogeneity. That is, the two quantities that are compared for percentage should be like quantities. If any figure is 0, then it is 100% smaller by a non-zero figure, but if any figure is 0, then it is 100% smaller than a non-zero figure, but a positive figure cannot be more smaller than 100%. Percentage can be a deliberate misrepresentation of facts. Now let us take an example. Suppose you go to a mall or a shopping complex and you come across various sales advertisements. They promote that you have 50% plus 30% plus 20% discount on a product. It doesn't mean that the product comes free. So you see, if percentages are not represented in a right sense, they convey a wrong message. If one figure is too big with the other, then the percentage comparison looks awkward. For example, I can measure a height of person and say suppose the height of person is 6 feet, and I can measure the height of Mount Everest and it is also in feet. But the size of Mount Everest is more than 100 times the size of a person. So in this case, if I do a percentage comparison, it looks very awkward. So in such conditions, we make use of other comparison like ratios and proportions. The basis of percentage can be unknown. So it is not known on what basis we are calculating the percentage of a definite data. For example, we collected information for some other purpose, and using that information, you can interpret a new result in terms of percentage. So there is no basis of finding the percentage. Now we come to rules of converting values into percentage. Let us see the first rule. Converting simple fractions into percentage. A simple fraction can be converted into percentage by multiplying the numerator and the denominator by the same quantity such that the denominator becomes 100. So our main intention is to make the denominator as 100 because we know that 1 upon 100 is percentage. Let us take an example. We have 3 upon 5. Here the denominator is 5. In order to make this denominator as 100, we need to multiply numerator and denominator both by 20. So in this way, our denominator becomes 100 and the numerator becomes 60. We can say that it is 60%. Let us take another example. We have 2 upon 7. Here 7 is in denominator and there is no one single integer value that can be multiplied to this 7 to make it into 100. So what we do in such cases, we will consider this as one value. That means it is 2 upon 7 whole upon 1. Here now we need to make this 1 as 100. So I have to multiply numerator and denominator both by 100. So we have 2 upon 7 into 100 whole divided by 100, which means we have 200 upon 700. We know that 1 upon 100 is percentage, hence the value reduces to 200 upon 7%. The next value is to convert decimal fractions into percentage. A decimal fraction can be converted into a percentage by multiplying and dividing the quantity by 100 such that its denominator becomes 100 and further solving it. Let us take an example. We have 1.35. Now we multiply and divide numerator and denominator by 100. So we have 1.35 into 100 whole divided by 100, which is equal to 135 into 100, and we remove this decimal, we have to add 100 in the denominator. So it is 100 into 100. Now 100 got cancelled, and we know that since 1 upon 100 is a percentage, the final answer is 135%. Let us take another example. We have 0.02. Now multiplying and dividing by 100, we get 0.02 into 100 divided by 100. Removing the decimal, we have to divide it again by 100. On solving further, we get the answer as 0.02% or simply 2%. Let us take another example. We have 0.0016. Multiplying and dividing by 100, we have 0.0016 into 100 divided by 100. Removing the decimal, we have to divide it by 10,000. So it is 16 into 100 divided by 100 into 10,000. 100 got cancelled. We know that 1 upon 100 is percentage. We still left with 100, so we put decimal points in the answer. So we have 0.16%. The next rule is converting percentages into simple fraction. It is just opposite to the first one. A percentage can be converted into a simple fraction by replacing the percentage symbol by 1 by 100 and expressing the fraction as a simplest fraction. For example, we have 24%. Here, on removing this percentage symbol, I have to write it as 24 upon 100. On solving further, it is 6 upon 25. So this is the simplest fraction which cannot be further subdivided. Take another example. We have 200 upon 9%. That is 200 upon 9 into 100. On solving, we have 2 upon 9. Next, converting percentages into decimal fractions. A percentage can be converted into a decimal fraction by replacing the percentage symbol by 1 by 100 and expressing the fraction as a decimal fraction. Let us see how. So we have 125%. Here, on removing the percentage symbol, I have to divide the value by 100. So we have 125 upon 100. On solving, we have 1.25, which is a decimal value. Let us take another example. 0.975%, which is equal to 0.975 divided by 100. On solving further, we have 0.00975, which is again a decimal value. Now, the next example is, it's a mixed fraction. We have 16 2 upon 3%. On solving this, we get 50 upon 3%. That means 16 into 3, which is 48. 48 plus 2 is 50. So this mixed fraction is first reduced into a simple fraction, which is 50 by 3%. On solving further, in place of percentage, I have used the value 1 by 100, and solving it, we will get the answer as 16.67 upon 100. Again, we have to put decimal like this, so we have to arrange it like we have answer as 0.1667. The next rule is to find a definite percentage of a quantity. It is obtained by multiplying that quantity by the rate percent and dividing the answer by 100. We will use the formula as the percentage value or the percent value is equal to quantity into rate percent divided by 100. Let us take an example. We need to find 12.5% of 50 kgs. So here the quantity value is 50 and our rate percent is 12.5. Using the above formula, we have 50 into 12.5 divided by 100. On solving this, we get 6.25 kgs, or we can say that 6 1 upon 4 kgs. The next rule is to find percentage of a quantity with another quantity. So here rate percent can be found out using the formula, that is rate percent is equal to quantity to be represented in percentage divided by quantity of which percentage is to be found out multiplied by 100. Let us take an example. What percent rupees 21 is of rupees 280? We need to find what percent rupees 21 is of rupees 280. So here, if you compare the values with the given formula, the quantity to be represented in percentage is 21 and the quantity of which percent is to be found is 280, since we need to find of what percent is 21 of rupees 280. So, we have the answer as 21 into 100 divided by 280. On solving this, we get 15 upon 2, or in mixed fraction it is 7 1 upon 2%. The next rule is to find the percentage increase and decrease of a quantity. Now here the increase percent is equal to the amount of increase divided by original quantity multiplied by 100. For example, if a quantity increases from A to B, the value of increase is equal to B minus A. So from the above formula, the percentage increase is equal to B minus A upon A multiplied by 100. Similarly, if there is a decrease, the decrease percentage is equal to amount of decrease divided by original quantity multiplied by 100. For example, if the quantity decreases from A to B, then the amount of decrease is equal to A minus B, and hence the percentage decrease is equal to A minus B upon A multiplied by 100. The next rule, to find successive increase or decrease of a quantity by a certain percentage. If the successive increase or decrease in the quantity is P0, B, R1%, R2% and so on up till Rk%, then value after k terms is equal to P of k, which is equal to the initial value P of 0 multiplied by 1 plus minus R1 by 100 multiplied by 1 plus minus R2 by 100 and so on up till 1 plus minus Rk by 100, where if there is an increase we will use the plus sign, if there is a decrease in the value we will use the negative sign. If increase or decrease is R% each time, that means there is no variation in the percentage. So, we can write it as P of k is equal to P0 1 plus minus R upon 100 whole raised to power k, where k is constant. Here if there is an increase we will use the plus sign, if there is a decrease we will use the negative sign. Let us look back what we have covered in this module. We started with what is percentage. We have seen the relationship between percentage, ratio and fraction. We have seen some properties of percentage, and we have seen rules for converting values into percentage. I hope this basic knowledge about percentage is enough for you to move ahead for the next module. In the next module, we would be looking at various problems that come across in percentage, and we will see some numerical and word problems. Thank you.